All right, I've got my Year 10 class here, and we're going to go through, we've just been through unions and intersections. Now what we're going to go through is what we call the addition rule. And the little starter activity that we've just talked about is that, if I get a little highlighter out, we've been told that the probability of A is 0.5 and the probability of B is 0.4. Now, of course, we've gone ahead and now you can see there that B is that column there, B. I've turned this into a two-way table. And likewise, the probability of A is 0.5 is there. Now, unfortunately, due to this, we can see there that we fill out this, all of these probabilities add to 1. We should be able to comfortably do those things. But we can't do anything else until we realise the important fact, this is very important when it comes to this, is use this thing here. Now, that doesn't give us in particular a great deal, but the probability of A or B, the probability of A or B, well, that's equal to the probability of A plus the probability of B. But what we've actually done is we've actually counted something twice. I'll show you what I mean. Okay, if I go ahead and here's A, if I was to add that and then I was to add this, what have we done? What have we done? We've actually counted the intersection twice. So we would have to subtract away the intersection. Does that make sense? Like, so by what we've done is if I was to get my highlighter out, if I work out what this probability is here, that's all of A. But remember, we've already counted the intersection. So there, but the intersection of B, if I was to get B, the B is in blue. I've actually counted that intersection. I've counted that twice. So therefore, what we have to do is subtract that away. And this is what we call the addition rule. Okay? It's the probability of A plus the probability of B minus the intersection is A union B. You're counting, otherwise you'd be counting it twice. Now, let's have a look then though. This A or B in terms of the table, if I'm trying to fill in a table, well, A, we're happy with A. So therefore, there you go, there's A. We know that that is A, that row is A. We know that this row is B. And that all is going to add, we've been told, yes, there's some overlap, we've been told that that's 0.8. So if that all adds to 0.8, that's the magic piece of the puzzle that we need, because that means that this guy in here, not A and not B, not A and not B, not A and not B, that must add to 0.2. Okay, now that we've got 0.2, we can then fill in the rest, can't we? Yeah, we can see that this row here is going to add to 0.5, so that would be 0.3. That column is going to add to 0.4, so that's 0.1. And you should be filling this in this as we go, rather than just observing. And you can also see that that row there, that must be 0.4. There you go. We've just done a two-way table, and we could answer any questions about that, such as, is it, now by the way, is this mutually exclusive? Is it mutually exclusive? Well, if we talk about before, mutually exclusive is when there is no intersection. Is there an intersection here? There must be some overlap. Is A intersection B 0? Is this 0? No. So are they mutually exclusive? No, they're not. Okay, so no, they're not. Because, and why? Because A intersection B is not equal to 0. Okay, there is an intersection. All right. We could answer all sorts of questions. So find the rule connecting A or B. So the probability of A, we could answer all of these questions from the two-way table now, looking at the columns and the rows. Okay. Now, what I was talking about, there it is. It's in there in your exercise. If you want want to cut that out and put it in your bound reference, go for it. I don't expect you to copy everything out. I do think that you would handwrite certain examples, but if you wanted to cut and paste that later and put it in your bound reference, go for it. What we're talking about is that, well, clearly we need to subtract away the intersection because we've counted that twice, haven't we? Okay, and also mutually exclusive, as I said, would look something like this. There is no intersection. A intersection B would have to equal 0 for two events to be mutually exclusive. They can't happen at the same time, which also means that if we go to our addition rule, if that's 0, if that's equal to 0, that's why we get this for mutually exclusive. If I'm subtracting 0 away, probability of A plus the probability of B. Okay, so this is a special case when they're mutually exclusive. Let's do an example. Okay, I would like you to try this based on what we've just been through. I'm going to pause the video now, okay, and I'm going to get the class to give this a go. All right, so this is my solution. As you can see, the addition rule. Let's write out what the addition rule is. I think it's also nice if you could write it out, you're going to get some marks if you made a mistake, still writing out the addition rule and then applying it. Maybe you make a silly mistake, but at least then I could give you a mark if you then wrote out and substituted those in. So there's your probability of A and B. And of course, what we've got to do is we've got to simplify that, and you could add probability of A and B to the other side. You can do it a number of ways. You could really guess and check. We know that 0.95, take away 0.05 is 0.9. That must be true. And likewise, that's what it would look like. You would not have to do that. I was just trying to show you where the rule comes from rather than just simply memorizing the rule. Okay, now what we're going to do is I'm going to go through this last example with you. I'll get you to fill it in with me as you go. Okay, and let's see if we can do this one. So we've got, let's read it. I'm reading it for the first time as well. Card is selected from a standard deck of 52 playing cards. No jokers. Let A be the event that the card is a diamond and B be the event that the card is a jack. Find the number of A. So what's the number of A? We're looking at for the cardinal number, how many diamonds are there in a deck? Sorry? No, it goes ace to 10 is 10. Jacks, queens, kings. How many different? There's 13 different denominations. Okay, ace 10, jack, queen, king. So the number, I might just do it over here. The cardinal number then of A, which is A, the event of the diamond, is going to be 13, isn't it? Yeah. What about B, which is jacks? How many jacks are there? There's 4 jacks. So the cardinal number of jacks is 4 jacks out of 52. 52 cards in a deck. What about how many how many diamonds are also jacks? 1. Yeah, so there's 1 out of 52. Now, what is the so just be very careful when you're doing this because the cardinal number and the probability are 2 separate things. What is the probability of A? Well, the probability of A is 13 out of 52, which of course is 1/4, isn't it? Leave it like so. What about the probability of not A? That's actually fairly straightforward. You shouldn't have to think about it and count 39 times. Archie says 3/4 because we know that the probability of an event and its complement must all add to everything or 1. Very good. What about the probability of A and B? Well, we're looking at one thing out of 52, aren't we? There is 1 jack which is a diamond in the deck, 1 out of 52. Now, it says use the addition rule to find the probability of A or B. So we're going to have to, let's write out our addition rule. This is where the probability of A or B, you could have it in your bound reference, but logically it's, well, if I have A and then I have B, and then I've just counted the intersection twice, so I've got to take it one away. If you understand how formulas, where they come from, you have a much bigger understanding rather than just trying to rote learn things. Okay, so there we go. Now let's use the addition rule. Now, by the way, we don't know what the A or B is, but we do know that the probability of A is 1/4, don't we? We've just worked that out over here. Okay, the probability of A is 1/4. And the probability of B, well, the number of B is 4. So there's 4 things, 4 cards which are jacks, and that's 4 cards which are jacks out of 52. Okay, so I'm going to call that 1 out of 13. All right, does that make sense? One thing that might be handy for this is not simplifying fractions, okay? Because when we're adding fractions, we want like denominators. So maybe let's, for this instance, usually not, it's a good idea for this one, if let's keep that as 13 out of 52, all right? And the probability of B, we're talking about, what's that, 4 out of 52. Okay. Probability of A intersection B, we've found that already, haven't we? So we're going to subtract 1 from 52. Okay, can you see that? Did you have a question? Did you have a question? Just no, all good. Okay, so what is the probability of A or B? I'm just going to pause it here. All right, so the answer then, now that they're all same denominator, is we're adding those 13, 17, 16 out of 52. Now it would make sense to simplify that because we know that 4 goes into 16, 4 also goes into 52. Let's simplify that fraction to 4 over 13. Now 13 is a prime number, which means that there's no factors other than 1 and 13. So we know that that fraction is now simplified. Our answer being A or B is 4 over 13. Now it says find the probability that the card is a jack or not a diamond. Well, we could use, I think the whole point is that we're using the addition rule, all right? Now, can I get you to just quickly try this one? Okay, and I'm going to finish up with this. I'm going to pause this video. If you're watching this video, pause it, have a go at this one, and I'm going to release my answers very soon. So pause it now if you're watching now. All right, so here's my answer to this one. As you can see, we've got the addition rule, writing that out, stating what we've got, and as you can see there that we have to find out what the probability of A intersection B is here. So that gives us 0.35. Likewise though, if I want to find, I've drawn for part B, we've asked to find A and not B. Well, you can see there that the probability of B is 0.6, the probability of A is 0.5. What we can then do though is we have worked out that the probability of A or B is 0.75. So that means that this plus this must add to 0.75, which means that we can then go ahead and fill out this would be 0.25, which of course is our answer. Okay, so this answer here is 0.25. And of course, once I find that out, I could then go ahead and fill out the rest of the table. That's about it for addition rule. Once you know unions and intersections, it becomes so much easier.